Okay, so we're going to look at the harder turning points now. I think we'll just go through one example. Should be plenty. So example 4. Y equals x, x add 4, 2x minus 1. Now, your first thing for the turning points is the same principles, dy by dx equals 0. So we've got to find dy by dx, but at the minute I cannot do that because we've got brackets. So the first thing we've got to do is multiply out these brackets. So let's go with that. 2x squared minus x and 2 by the 4 plus 8x minus 4. So y equals x, 2x squared, add 7x minus 4, just tidying up. Now timesing everything by the x. Now, I'm trying to find dy by dx in my instructions over here. So let's do that. Power to front, take 1 off. Power to front, take 1 off, and x disappears. I've got to put the equal to 0 now. So 6x squared, add 14x minus 4 equals 0. You could try to factorise that if you want, but I wouldn't even start. I would just go straight for the formula. So you can see why these are harder. But it's still the same principle. You set dy by dx equals 0 and you solve it. So I'm going to be using the formula. So just writing it out here. So x is minus b plus or minus b squared. So 14 squared is 196 minus 4 times a times c. Just be careful of these negatives. All over 2a. So that works out to be minus 14 plus or minus 196 plus 6 times 4 times 4 plus 96 over 12. Now if you remember how you split that up. So it's minus 14 plus 196 add 96 is 292 over 12. And the second answer is minus 14 minus 292 over 12. And putting this into the calculator, you get x equals 0.257 and the other answer. When we did it in the first section of these, we only had one x. I've got two x's. So we'll have to just run with the two x's. Remember what the second stage was find out what your y was. Now, it doesn't matter if you use that equation or this one. It doesn't make any difference whatsoever. I'll use this y. I'll write it out again to save me getting lost. So you put each x in turn. So I would write down when x is 0.257, y equals 2 times 0.257 cubed here, plus 7 times 0.257 squared, minus 4 times 0.257. And if you work all that out in your calculator, you should get your y to be minus 0.532. So that's one coordinate. And you've got to do it all over again for the other x value. Try to keep them side by side, makes it a wee bit easier to follow your work. So when x is minus 2.591, you can imagine how many mistakes we made here with the minus sign. So put your x in. So it's 2 times minus 2.591 cubed plus 7 times minus 2.51 squared minus 4 times minus 2.91. And if you put all that into your calculator, you should get out 22.569. It might take a few attempts to get there, but that's the number you should end up with. A lot more work in these ones, but the same principle. Number 3, you want the nature, so you need your second derivative. If I go back up here, see where I've got divided by x, differentiate that again. So it's 12x plus 14. This is one of these occasions where you've got the x in it. So you've got to substitute each x in turn. So we'll just go through the same rigmarole. So when x is 0.257 for this side, your second derivative is 12 times 0.257, add 14. And if you work that out, you get 17.084. So it's bigger than naught, so it's a minimum. So this side was a minimum. 0.257 and minus 0.532. And then we've got the same for this one. So when x is minus 2.591, your second derivative, there's there, put your x value in, and if you work that out, you get minus 17.092. So it's less than naught, so it's a maximum. So your second answer is a maximum. So my advice to you whenever you're doing these, everything starts off the same. Turning point, dy by dx equals 0. So over to the side and do dy by dx. Then you put it equals 0. If it's an easy one like we had in the last exercise, it's a wee linear equation. This is not, it's a quadratic. Either factorise or use the formula. Get out your two answers. Second bit is find your y coordinates. So put your y equation down. It doesn't matter which y equation you use. Then put each x in turn and work out the y coordinates. So you've got your points. Then the third bit is your nature. So you differentiate again to get this. Then you've got the x here, so you've got to substitute in each x in turn. So work out. If it's bigger than 0, it's a minimum. If it's less than 0, it's a maximum. Now these are quite long, so I would say if we did about 3 out of exercise 8b, it'd be more than enough. So if we do exercise 8b, we'll do question 1. And if we do question, it's not as hard as what I've just done, we'll do question 1, we'll do question 8 and question 13. And I'll put the answers up shortly.